Imagine walking into a high-end juice bar. You just want a quick drink, but you freeze. You're staring at a menu grading every single option on a list of 7 different variables, from tartness levels to organic certification. Your brain naturally recoils at that much chaos. Instead of juggling 7 separate characteristics for every cup, you want to compress that information into a couple of broad, actionable choices. You want to know if this is a sweet treat or premium health. To automatically find those broad categories inside massive sets of information, researchers feed the raw data into a mathematical algorithm called factor analysis. But the computer algorithm has a blind spot. It doesn't understand juice. Its priority is simply chasing the biggest patterns of numerical variation. It groups unrelated columns of data together just because the numbers happen to fluctuate in a similar way. Relying strictly on that raw mathematical spread creates groupings that are accurate on a spreadsheet, yet offer no utility for human decision-making. This scatterplot shows that initial computer output. The crossing lines are our broad categories, and the 7 dots are our juice traits. Notice where they landed. The individual traits float awkwardly in empty space, halfway between the horizontal and vertical axes. That halfway position creates a muddy middle. A dot dead center becomes an unnameable blend of price, sugar, and tartness. We cannot solve this by manually moving the dots. These coordinates are immutable real-world measurements that must stay exactly where they are. The data is locked into position, and the resulting picture remains unreadable. We are trapped in data paralysis. If the data points cannot be moved, we have to find a geometric workaround. We have to alter the framework surrounding them. This is where we apply a mathematical technique called Examrace rotation. It shifts our perspective on the numbers without altering the factual reality of the measurements. Watch the grid lines on this chart while the juice data remains frozen in its original coordinates. We slowly rotate the axes clockwise by 15 degrees. This slight spin sweeps the lines into alignment with the data clusters, forcing every dot to pick a side, dropping to almost 0 on one line while clinging to the other. By shifting the lens rather than the numbers, the data's inherent alignment becomes visible. Now our categories have distinct identities. The newly aligned vertical axis cleanly isolates traits like sugar and thickness, which we can group together as a taste profile. At the same time, the newly aligned horizontal axis isolates price and organic certification into a premium choice. This specific spin, where the vertical and horizontal lines are kept at a rigidly locked 90-degree angle to one another throughout the entire turn, is called orthogonal rotation. Orthogonal rotation forces a clean, binary choice, turning a mathematical mess into 2 distinct concepts a human can actually read. But the physical world rarely cooperates with perfect 90-degree geometry. In nature, traits don't naturally fall into isolated, rigid boxes. In reality, highly premium organic juices usually trend toward being thicker. Because the concepts inherently overlap, keeping the chart locked at a strict right angle doesn't capture the whole truth. To handle this messy reality, statisticians rely on a slightly different method called oblique rotation. Watch the axes on the chart. Instead of holding a rigid corner, the lines unlock. They tilt and bend inward toward one another to trace the nuanced spread of the dots. Allowing the mathematical framework to bend ensures our final categories reflect the overlapping truth of nature, rather than forcing reality into an artificial square. Returning to our juice bar, the paralyzing wall of menu text is gone. By clarifying those broad categories, we've translated an overwhelming dataset into an intuitive choice. As you watch this turning kaleidoscope, you're seeing the visual metaphor for factor rotation, chaotic, abstract shapes naturally aligning into recognizable symmetries. Inside the tube, the physical colored stones never change. Nothing is ever added and nothing is ever removed. Turning the lens until the colored stones settle into a recognizable pattern allows us to clarify a mountain of raw measurements into key insights.